Hey guys, this is Cloud Mentor here. I would like to talk about elimination reactions. Specifically, it is E2 reaction. Let's take a glance at the scenario here. Yes, an elimination reaction is a type of organic reaction in which two substituents are removed from a molecule in either one or in two-step mechanisms. Yes, it is the elimination reaction means the elimination of or the removal of two substituents from a molecule that will be in one step or in two steps. Depending upon the number of steps, there are two types of reaction. The one-step mechanism is known as the E2 reaction, and the two-step mechanism is known as E1 reaction. Okay, and the numbers refer not to the number of steps in the mechanism, like that of the nucleophilic substitution reactions like SN1 and SN2 reactions, but rather to the kinetics of the reaction. E2 is bimolecular, that means it has second order kinetics, and while E1 is unimolecular, having first order kinetics. So in any elimination reaction, two groups from adjacent carbons are removed and replaced by a double bond between those two carbons. So let's take a look at the reaction mechanism. Here is just a bromopropane, and so here is bromine, hydrogen, and two adjacent carbons are here. So what's going on here? Going on here is some nucleophile. Let's say it is hydroxide. In this case, instead of doing a substitution reaction, we are going to do an acid-base reaction. Okay, that means that a proton will be extracted. So notice that. The arrow goes from the hydroxide directly to this proton. Okay, and then the electrons in the proton and or the carbon hydrogen bond are going to go and form a double bond between these two carbons. Okay, there's this bond pair of electrons are going to form a double bond between these two adjacent carbon atoms, and then just as with a substitution reaction, a leaving group must leave. Here it is the leaving group, that is bromine, must leave from the this molecule. So this is what is left: a propene molecule, that is a water molecule, and a bromine or the bromide ion. And so basically, one thing that is important to keep in mind in an elimination reaction is that it is a beta elimination reaction. What is beta elimination? What do you mean by beta elimination? If this is the leaving group, that is bromide, here it is bromine. Bromine is the leaving group. It is, then this carbon will have the alpha position, and this is the beta position. Yes, this is the beta position. This is the alpha, and this is the beta position. Right? It is a proton on the beta carbon that is removed because it is not going to work out to remove a proton at the alpha position, because then those electrons will have nowhere to go. Where can they go? Like from what happened in the beta position. Okay, instead what happens is that this carbon is able to receive the electrons in this carbon hydrogen bond, and these are the electrons that form the pi bond here. This is pi bond, double bond have a pi bond, and one is sigma bond, because this carbon can also lose the electrons that are now belonging to the bromine. Okay, this carbon can also lose the electrons to the bromine, which is the leaving group. So let's take a look at the transition state of this reaction to better understand this mechanism. Okay, and just like the SN2 reaction, that too in referring to a bimolecular transition state, meaning that the substrate is attached to the substrate here is attached to both the leaving group and the proton that's being extracted at the same time, making this is a concerted reaction. It happens all at once in one step. So here we can see that the hydroxide is forming a bond to the proton. Here this hydroxide is forming a bond to the proton, and carbon is weakening. The carbon hydrogen bond is weakening. As well, the bond between the carbon and the leaving group. Here it is the bond between the carbon and the leaving group is weakening, and the pi bond begins to materialize, or it comes into action. So this happens all at once. It is not the case the hydroxide extracts the proton, then at a later time the electron goes to form the pi bond, and then once the pi bond is being formed, the carbon realizes that it has too many bonds and loses a bond to the leaving groups. It's not the case like that. This is not like that. In fact, all these bonds are materializing and dematerializing at once. So there is the transition state and then the final product with the pi bond in place. That's all. So now it's time to look around some important points on the E2 mechanism or E2 reaction. They are, in most organic elimination reactions, at least one hydron, that is hydron H plus, hydron is lost to form the double bond. The unsaturation of the molecule increases. Yes, in all elimination reactions there is a loss of hydron, at least one hydron to form a double bond. That means the unsaturation of the molecule. And the second point is that E2 is a single step elimination with a single transition state. We have seen that, right? And the next point is typically undergone by primary substituted alkyl halides, but is possible with some secondary alkyl halides and other compounds. Yes. And the next thing, the reaction rate is second order because it is influenced by both the alkyl halide and the base. That is, the reaction is bimolecular. The reaction rate is dependent on the concentration of both the alkyl halide taken and the base. Okay. And the next point, because the E2 mechanism results in the formation of a pi bond, there must be two leaving groups, often a hydrogen and a halogen. That is, to form a pi bond there must be a loss of two, there must be two leaving groups. Okay. And the next point is E2 typically uses a strong base. Yes, there must be strong base in order to remove the weakly acidic hydrogen. And now, in order for the pi bond to be created, the hybridization of carbon need to be lowered from sp3 to sp2. Yes, when there forms a double bond, the hybridization changes from the sp3 hybridization to the sp2 one. Okay, that's all for today. Hope you guys understood the topic. Thanks for watching my video. You're always free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.